The strength and power to move things. Daihatsu Diesel. Daihatsu Diesel's advanced technology and unparalleled reliability help move the world. On the ever-changing sea, Daihatsu Diesel marine engines help vessels of all sizes run safely, from large ferries and large-sized merchant vessels to small fishing boats and utility craft. In recent years, Daihatsu Diesel land engines have contributed to society with its advances in energy-saving devices, environmentally conscious technology, and advanced computerization. Daihatsu Diesel also provides first-rate after-sales service for first-rate engine performance. A 24-hour computerized system that controls over 3,500 types of parts allows for fast, precise maintenance. Daihatsu Diesel's vast network of domestic and international port cities offers a complete global service system. Daihatsu Diesel's breakthroughs in research, development, and technical innovation promise to lead the industries of the 21st century. Catch a small glimpse of these breakthroughs through this video. Daihatsu Diesel developed the DK20 on 5 basic themes: reliability, lightness, miniaturization, inexpensive maintenance, and environmental awareness. Here is the ratio of flexibility to mechanical strength of the DK20. Daihatsu Diesel has been working on reducing exhaust emissions for over 20 years. The result is Daihatsu Diesel engines now satisfy IMO regulations with no increase in fuel consumption. They've become environmentally friendly. Its dismantlement and assembly times have significantly decreased. The ISO requires cylinder 1 to be located on the flywheel side. This video shows the proper maintenance procedures for the model DK20. It deals with 4 sections: the cylinder head, pistons, connecting rods, and main bearing shell. First, the cylinder head. Prepare all necessary tools for dismantling. Before dismantling the cylinder head, set the governor handle to stop and turn off the air at the mains. Next, turn off the water cooling system, fuel oil system, and the lube oil system at the mains. Then drain the cooling water from the engine. Remove the cylinder cover. Remove all pipes around the cylinder head, namely the nozzle inlet and outlet pipes for cooling. The starting air pilot pipe. And the outlet pipe flange for water cooling. Next, remove the bolts to the high-pressure fuel oil block. At this point, use compressed air to blow all fuel from the fuel oil block. Cover it so that no debris enters the fuel oil outlet of the injection pump. Remove the inlet connectors of the nozzle holder. Remove the exhaust pipe. Be careful not to confuse the stainless steel exhaust pipe attachment bolts with other bolts. It's unnecessary to remove the intake band. Loosen the rocker arm tightening nut. Remove the rocker arms and the valve push rods. Use the proper tool to pull out the nozzle holder. Install the hydraulic jack. Then screw on the pulling bolt. Make sure the notch faces outward so that the jack stand does not touch the cylinder head. Before applying pressure, turn the hydraulic piston into the hydraulic cylinder as far as it will go. Mount the jack into the pulling bolt, then twist it back a half turn. Raise the oil pressure to the regular level. Loosen the fixing nut. Then lower the oil pressure slowly with the pump's release valve. Use the special tool for lifting the cylinder head. Remove the cylinder head. It's also possible to open up the cylinder head without removing the rocker arms. After removing the cylinder head, be sure to place a cover over the cylinder liner and intake pipes to avoid getting any dust or debris into the engine. Be careful not to damage the bottom of the cylinder head. Use the special tool to simultaneously remove the 4 intake and exhaust valves. Before maintenance, check for carbon buildup on the combustion surface and intake and exhaust ports of the combustion chamber. Be sure to clean the combustion surface properly. Next, perform a color check. You'll need to pay special attention to the combustion surface because it's exposed to high pressure and high temperatures. The stem diameter of the intake and exhaust valves are measured at 3 different points with a micrometer. Use vernier calipers to measure the thickness of the valve seat height. Also use calipers to measure the inner diameter of the intake and exhaust valve guides. Record your measurements. Lubricate the valve stems with oil, then grind the intake and exhaust valves. Use various grades of carborundum. When using a coarse grade, grind the valves by tapping. Use the finer grades for finishing work. Here you grind the valves by turning. Wipe off the carborundum completely. Then check the points of contact with bearing blue. Make sure there are no scratches, debris, or any sign of damage or corrosion on the surface of the valve springs, or no sign of wear and tear or damage on the seat. To reassemble the intake and exhaust valves, just reverse the order of the dismantling procedure. However, note the slit on the stem top of the exhaust valves. Before reassembling, change all stem seals. Be sure that all the valve cotters are sound. Next, the procedure to dismantle the starting air valve. First, remove the cover and pull out the starting air valve. Dismantle it, clean all parts, and reassemble it. Then grease the starting valve. Insert the spring, the piston, tighten the nut and divide the split pin carefully. The split pin is made of stainless steel. During reassembly, be sure to change the O-rings and packing. Grease them before reassembly. Then tighten the bolts to the prescribed torque. Now we'll dismantle the fuel oil injection nozzle. Clean all parts during this procedure. Check the injection holes at the tip of the nozzle. Attach the spacer to the nozzle holder. Then insert the nozzle tip. Spray Molykote on the holder screw and retaining nut seat before tightening them to their prescribed torque. Attach the nozzle tester and set the injection pressure. Loosen the holder adjustment screw. Set it to regular pressure before tightening it. Make sure the nozzle sprays properly a couple of times at 300 kilograms per square centimeter. Avoid touching the nozzle while performing the test. Make sure that oil does not leak from the nozzle tip injection holes. Clean the seal parts of the cylinder head and the cylinder liner of the engine frame. Replace the cylinder head gasket. Cooling water guide O-rings, starting air valve body O-rings, pushrod rubber seals, and intake bend seals. Remove any extraneous substances from the cylinders before reattaching the cylinder head. Make sure the nuts face up before screwing them on. Install the hydraulic jack the same way you took off the nuts. Tighten the nuts firmly by using a hammer to tap the tool handle. When reassembling the nozzle holder, check for any remnants of the old gasket before installing a new gasket. Two bolts are tightened to the prescribed torque. Turn the flywheel to the combustion top position. Then insert the push rods. Loosen the valve guard T-screw. Apply the dial gauge to the adjustment screw on the rocker arm side. Tighten it until the gauge needle moves. After finishing the adjustments, tighten the lock nuts completely. Loosen the rocker arm adjustment screw before replacing the O-ring under the rocker arm. Then set the rocker arm metal piece and attach the rocker arm. Adjust the rocker arm gap with the thickness gauge. Then tighten the lock nut. Make sure the seat surface of the inlet connector is clean before attaching the inlet connector. Tighten it to the prescribed torque. Replace the top O-ring of the fuel oil injection pump. Now make sure the joint and seal of the fuel oil high pressure block is clean and damage-free before attaching the piping. Tighten the bolts to their prescribed torque. Reattach all piping around the cylinder head and replace all gaskets and packing. Now let's take a look at the valve operating device. To remove the intake and exhaust swing arms simultaneously, remove the swing arm attachment bolt as if transmitting a cam movement to the push rods. You can tell the difference between the intake and exhaust swing arms by an engraved mark on the shaft side. R means exhaust. If the rollers have too much play, change the swing arm. Check the gap between the intake swing arm, marked with an L, and the roller in the same way. The swing arm attachment bolt is special. It also acts as an oil application joint. Tighten these bolts to their prescribed torque. Next, fuel oil injection pump maintenance. First, remove the fuel oil injection pump. Fix it to a vise, then remove the stopper pin by pushing the tappet. Next, remove the following in this order: the tappet, plate, spring seat, spring, plunger, spring seat, control sleeve, control rack, and deflectors. Now remove the delivery valve assembly. However, do not dismantle the delivery valve. Remove the stopper bolt and set screw for the air breather. Remove the plunger barrel. Just push it up from the bottom. Next, make sure there's no cavitation on the barrel. Plunger and deflectors. Wash and blow all parts. To reassemble the fuel oil injection pump, start by making sure that all the parts are organized. Remember to replace all O-rings and backup rings. Insert the barrel. Grease the O-ring, then line up the bolt hole with the barrel groove. Grease the O-ring before attaching the delivery valve dowel pin. Spray the bolts with Molykote. Then tighten them to their prescribed torque. Mesh the control rack teeth to the control sleeve teeth. Then move the rack. Check for easy movement and stroke from 0 point from the O-ring to the full rack. Check the height of the fuel oil injection assembly by checking the tappet slit. Use shims to adjust the assembly's height. Next, piston and connecting rod maintenance. Put the piston in the bottom dead center position. Use sandpaper to remove carbon buildup in the combustion chamber of the cylinder liner. Use a thread tap to remove carbon from the piston hanger screw holes. You don't have to dismantle the large end of the connecting rod when removing a piston. Before removing the piston, remove the wiring. Now remove the connecting rod bolt. Next, attach the piston hanger fittings to the upper part of the piston. Then pull out the piston. Cover the cylinder liner so no foreign substance or debris gets into the engine. Lift the connecting rod slightly. Remove the retaining ring on one side, then pull out the piston. Check for damage or carbon buildup. Check the chromium plating and check for carbon deposits on the piston rings. Use sandpaper to remove carbon deposits on the combustion surface, but do not use sandpaper for the skirt. Perform a color check to check for cracks on the combustion surface. Now measure the piston. Piston pin bore. Ring grooves. Connecting rod small end bore. Piston pin. And piston rings. Remove the cylinder head packing and O-ring and clean the cylinder liner. Measure the inside diameter of the cylinder liner like this. Open the connecting rod large end board to check and replace the crank pin bearing shell and crank pin bolt. Then turn the large end bore sideways. Then turn it toward the cap insertion tool. Remove the wiring. Now loosen the crank pin bolt. Support the large end bore from both sides, then remove the bolt. It's pulled out from both sides to avoid damaging the crank. On the bearing shell back and joint surface, check for fretting, substance buildup, or any foreign objects. Use a spherical micrometer to check the amount of abrasion. Check for damage or fretting on the serrated joining surface and rod part. Perform a color check to check for cracks on the serrated surface. Check for damage and abrasion on the screw and mating surface of the crank pin. The crank pin bolt and connecting rod connecting bolt may have wear due to embedding after long operation. If this is found, a new tally mark must be applied. Tighten the crank pin bolt at torque A without the bearing shell. Spray the mating surfaces of the bolt with Molykote. At the prescribed torque, tighten the bolts to this order: 1, 4, 2, 3, 1. Make a connection mark for torque A on the bolts, then tighten them to the B mark. Follow this same procedure when inspecting the connection rod connection bolts. Before putting a torque A mark on a new bolt, put the old bolt number on it and tighten it a couple of times so that it fits to the torque B mark. You can measure the inside of the large end bore when the bolts are tightened to their prescribed torque. Now let's assemble a connecting rod large end bore. Clean off the rear surface of the housing and bearing shell. When assembling the bearing shell, make sure the claws are fitted in the right position. At this point, do not grease or oil the rear of the bearing shell. Clean the crankshaft and put oil on the bearing shell. The bearing shell is assembled from both sides to avoid damaging the crankshaft. Make sure that the connecting rod large end bore is assembled according to cylinder number. And make sure that the embossed surface faces the opposite side of the direct connection. The assembly order is determined by the numbers on each bolt. Be sure to spray the mating surfaces of the bolt with Molykote. Hand tighten each bolt as far as it can go. Now use a torque wrench to tighten them to torque A. The order is 1, 4, 2, 3, 1. Next, use the same procedure to tighten the bolts in order from the connection mark on the bolt side to mark the B position on the connecting rod side. Turn the bolts till they stop. Before assembling a piston, wash and blow all parts. When fitting an oil ring, its manufacturing mark should face upward. Assemble the coil so that the coil joint faces the opposite side of the ring open end. Now attach them. When assembling a piston and connecting rod, match the embossed surface on the lower part of the connecting rod to the F mark on the piston's combustion surface. Insert the piston pin. Now insert the piston pin retaining ring into the groove. Apply oil to the piston rings, making sure that the open ends are staggered by 90 degrees and are not in alignment. Place the piston insertion frame into the upper part of the cylinder liner. Apply oil to the cylinder liner. Move the crank pin to the lower dead point. Slowly insert the piston into the cylinder liner. Bring it down gradually. While joining the large end board to the connection rod lever, also join the knob. Spray the mating surfaces of the connection rod connection bolts with Molykote and attach them according to their identification numbers. Tighten the connection bolts at an angle to mark B, the same way the crank pin bolts are tightened. Check thoroughly for lateral movement before turning them till they stop. Let's move on to the main bearing shell maintenance procedure. Remove the side cover. Prepare the necessary tools. Remove the side bolt cap and install a hydraulic jack to the side bolt. Raise the jack on both sides of the side bolt while applying the prescribed pressure. Loosen the nuts. Next, lower the pressure gradually with the pump release valve. Attach the hydraulic ram holder fittings to the main bearing shell cap and set the hydraulic jack mounting tools. Install the hydraulic jack. Turn the handle on the lower part and raise it until the jack reaches the main shaft holder bolt. Attach the hydraulic jack to the main shaft holder bolt. Apply pressure and loosen the nuts. Remove hydraulic ram 1 from the main bearing bolt. Insert the cusp of hydraulic ram 2 into the hydraulic ram bearer and fasten ram 2 with the proper bolt. Remove the side bolt. Switch over to the hydraulic ram by slowly turning the main metal cap valve toward the ram. Then remove the main metal carefully. Do not pull the main metal cap from the spigot joint completely. Insert the metal extraction tool into the hole of the crankshaft. Be careful not to let the tool slip from the oil hole. Turn the metal extraction tool 180 degrees until it makes contact with the upper metal. Then remove the upper metal. During this process, take care not to scratch or dent the upper metal. Inspect the inner and rear surfaces of the upper and lower pieces of the metal for scratches or any other irregularities. Next, use a circular micrometer to measure thickness. Let's move on to the needs and requirements of the main bearing shell assembly. This piece with the oil groove is the upper metal. Ascertain the position of the housing notch and metal claw. Make sure the inner surface of the metal is clean. Then, with your hand, push the metal away from the claw-free side. Use the metal extraction tool to turn the crankshaft in the direction of the housing. When the metal and the housing are properly aligned, remove the metal extraction tool. Then you'll be able to use a mirror to check the condition of the metal. Next, use your hands to check the crankshaft for scratches or foreign matter. Check the lower metal, main metal cap, and position of the claw. Do not apply oil to the back of the metal. Attach the lower metal. Use your fingers to apply oil to the inner side of the metal. Raise the main metal cap. Apply molykote to the side bolt. Screw it in completely. Then twist it back a half turn. Next, set the hydraulic jack. To attain the prescribed pressure, simultaneously place the two metal cap bolts in their holes, and with a hammer, tap their handles to set the bolts in place. Then tighten the side bolts the same way as the main metal cap bolts. After the operation, open the crankcase and check to see if the lubricating oil priming pump is working and lubricating properly. Check to see if it turns easily. When the maintenance process is properly completed, the engine should run effortlessly. Go over various parts of the engine by touch to check for any abnormalities. Stop the engine. Remove the side cover and check the temperature of the bearings. At the same time, check for abnormalities. You've just seen the periodical maintenance process for the DK20. For further information, please consult the manual. Here are some points to remember. Be aware of safety clothing. Correct understanding and pursuance of signals. Be tidy and neat. Keep working conditions in good order. Be tidy and neat. Keep control of tools. Keep measured data. Use genuine parts. Look for tally marks. Tighten to the specified tightening torque and tighten to the specified hydraulic pressure. Keep the correct maintenance intervals. As seen in this video and noted in the instruction manual, proper maintenance is necessary to ensure your engine's long life and efficiency.